citizens of Singapore. You're watching NTU on News to You. Tonight, I have two breaking news for you. First, on May 10th, a bomb was planted in the city, set to explode in 6 minutes. Fortunately, Spiderbot was assigned to the case. To defuse the bomb, he must collect an 8-part password scattered across buildings. Spiderbot must visit each building and send the images of the password parts back for recognition. After that, on May 17th, Spiderbot's girlfriend was kidnapped to a forest hideout as part of a revenge for defusing the bomb. To rescue her, he must follow directional arrows she left behind, left and right turns, hidden obstacles. Speed and accuracy will determine success here. Thankfully, he's backed by MDP Group 38. Let's find out how he did it, starting with the Android team. Let's head to the on-site interview.
Android team, how did your tech help the Spiderbots find the building in time?
So our Android app actually serves as Spiderbot's mission control, and we've created a Spiderbot beautifully designed in a red and blue theme. So the key feature placed in the center of the app is the map. It represents the robot's world, and we visualize the obstacles by placing it onto the map.
Like in the Spider Radar, we utilize that key tag to connect our application to RPi. It scans for a device with a working Bluetooth connection, then connects with the selected device once the button is clicked. Lastly, we have the command control that keeps tracks of the movement of the robot. It shows all the logs of the robot from the movement to the image detection. Not only that, it serves as a manual override in the case of an emergency. You can send commands to stop the robot and change the direction of this movement.
Next up, the RPi team, the heart of communication.
So the RPi acts as the central hub of the operation. It bridges the communication by receiving the city layout from the Android and passing it to the algorithm for pathfinding, and then relaying the final route to the STM controller. It also has a camera which captures images to help the Spiderbot identify each building along the route. When the RPi receives a snap instruction from the STM, it activates the camera and snaps an images. The image is then passed through the image recognition model to identify the buildings.
The Spiderbot uses a YOLO model which operates from a flash server that processes the image in 0.5 seconds. It is trained with many sets of images in different backgrounds and buildings. It saves the images along the bounding box, and when all the buildings along the route are identified, stitches them together into a collage. For task 2, when Spiderbot needs to decide on the next course of action, the RPi guides it by taking a picture and passing that image to the image recognition model. When multiple bounding boxes are found, the RPi will ignore the bull's-eye distractions and focus on the objective direction, helping Spiderbot to act quickly in the rescue operation.
Next, let's interview the algorithm team.
Firstly, we mark cells around the obstacles as invalid to allow enough clearance for the Spiderbot's movement through obstacles. We implemented A-star search for path planning to determine the shortest collision-free route, applying higher turn penalties to promote smooth motion. The algorithm also accounts for the robot's facing direction, ensuring correct alignment at each photo point. Finally, we optimized the overall route using a Hamiltonian path solver so the Spiderbot visits every target efficiently. To accurately represent the Spiderbot's real-world movement, we modeled the true displacement during turns by calculating the X and Y coordinate offset after each turning action. This ensures the simulated path reflects the actual arc-like motion of the robot, improving both path accuracy and realism.
And finally, the STM team, the muscle of our mission. Over to you.
So what we have developed is a STM32 controller that powers and enables the robot to maneuver around obstacles and be directed in real time. The ultrasonic and IR sensors detect obstacles and walls, while the gyro measures angular velocity and helps maintain balance during turns. The magnetometer provides directional heading, allowing the robot to stay oriented and navigate accurately.
The motors and servo control direction, speed and distance tracking with PID controls to eliminate deviations. Together with the optimized turn handling and UART communication, these components ensure smooth, stable and reliable real-time performance.
Yes, was that? Ladies and gentlemen, we have received live footage of Spiderbot at both incidents. First, starting with the bomb situation. Let's head to the live footage. Next, we will show footage of Spiderbot navigating and rescuing his girlfriend. Phew. What a close call that was. Thanks to MDP Group 38 combining Android control, RFI communication, STM precision, and algorithm intelligence, Spiderbot once again saves the day.